Imagine sitting in your exam hall. You turn the page, see a question on clock speed, and you smile, right? You've memorized the textbook. You write down that exact flawless definition you spent hours drilling into your brain. But then results day hits, and you lost the marks. Well, today we are skipping the fluff. We're diving straight into the 3-move chess trap examiners set for students who rely purely on rote memorization. We're going to completely dismantle the clock speed trap for the 0478 syllabus.
It's a painful reality, and honestly, it shocks thousands of students every single year. You might be wondering, how is it even possible that writing a flawless, textbook definition on your exam paper often results in absolutely 0 marks? Well, the answer lies in how Cambridge structures its mark scheme. You see, examiners aren't looking for a human photocopier. They don't just want to know if you can recite what clock speed is. They want to know if you can actually use that concept to solve a specific digital problem. If your answer lacks a specific, scenario-based application, boom, you've already stepped into the trap.
If you look at the examiner reports, they consistently highlight one golden rule. Generic responses rarely gain full marks. And the stakes here are incredibly high. A generic response will literally wreck your grade boundary. The examiners demand, they absolutely insist, that you anchor your explanation to the exact digital scenario provided in the question. So whether that's a school network, an automated factory, or a smartphone, if your answer could apply to just any computer, you aren't getting the marks for this computer.
Section 1. The Context Trap and Why Ordinary Revision Fails. So why does this happen? Well, most students fail because they walk into the exam hall and just dump everything they know onto the page without any direction. They completely miss the core requirement of the question. You can't just write that clock speed is measured in hertz and means more cycles per second and call it a day. That's ordinary revision, and we need dense, structured analysis. The first quick win to elevate your grade is avoiding the classic wrong turn of confusing similar terms. Our source material highlights that computer science mistakes frequently pop up when learners blur the lines between nearby concepts. When you do this, it immediately signals a weak theoretical foundation to the examiner.
Take a look at this. Memory versus storage, logic processing versus arithmetic processing. These are absolutely not interchangeable words. If a question asks how clock speed affects the arithmetic logic unit processing sensor data, and you start rambling generally about saving files to storage, you've missed the target. Dense revision has to train your brain to constantly compare these concepts, not just memorize them in a vacuum. You have to know the boundaries of a term just as well as its definition.
Section 2. The Disciplined Path, Moving from Concept to Application. In a moment, I'll show you the exact examiner clue in the syllabus that changes a 0-mark answer into a top-band score. But first, you need the analytical framework that makes that clue completely obvious. This is the methodology that forces you to move away from rote recognition and into structured scientific reasoning. Here it is. Step 1. Identify the exact requirement. Do they want causes, effects, or a design decision? Step 2. Classify the relevant components. Are we talking about hardware, software, or data? Step 3. Explain the sequence clearly so another learner could follow the steps. And Step 4. Connect it right back to the context. Concept, evidence, scientific reasoning, and finally, examiner wording. That sequence is your master key.
Section 3. The 4-prompt structure, your exam day checkpoint.
Okay, so how do you actually make sure you use that framework under time pressure? You use this really reliable memory structure as a mental checkpoint before you submit any exam answer. It's how you guarantee you haven't left any marks sitting on the table. I want you to challenge yourself right now. Think of the term clock speed and answer these 4 prompts out loud. What is it? How does it work? Where is it used in the exam scenario? And why is a higher or lower speed better or worse for that specific user? If you can seamlessly cover the process, the application, and the evaluation, your topic is ready for exam use. But if you stall on where is it used, actually, scratch that. If you hesitate on any of them, you need to go back to your notes.
Let's do a quick pause and predict. Look for the scenario context. Seriously, whenever you open a past paper, before you even look at the dotted lines where you write your answer, you have to spot the examiner's clue. Are you analyzing a smartphone, a wide area network, or an industrial robot? That single clue dictates exactly how you apply those 4 prompts. Think about it. A faster clock speed in a smartphone might mean faster app loading, right? But in a robot, it might mean faster reaction times to safety sensors. Context is quite literally everything.
Section 4. Spot the error. Flawed versus top-band answers.
Let's see how this builds in reality and physically demonstrate the massive gap in marks.
A classic flawed student answer looks exactly like the one on the left. Clock speed is how fast the CPU runs. That is the generic textbook definition trap in action, 0 marks. But look at the top band answer on the right. Higher clock speed allows the embedded system to process sensor data faster, improving robot reaction time. Look at the precision there. It names the specific system, an embedded system. It names the data, sensor data, and it gives the exact consequence, improving robot reaction time. That is how you win the marks.
Our source material reinforces this examiner-style feedback perfectly. Name a device or method and explain how it works. It is a two-part lock, guys. Top marks require both precise terminology and a clear sequence of process steps that directly connect to the scenario's consequences. You absolutely can't just give an advantage with no underlying reason or name drop a component without explaining its specific job in that environment.
Section 5. The 3-pass revision cycle. Building exam adaptability.
So to ensure you never write a generic answer again, this is the practical application of your studying. This is how you avoid falling back into the generic wording trap when the pressure is really on. Here is your study blueprint. Pass 1, secure the key definitions and contrast those tricky, similar terms we talked about. Pass 2, practice the actual process flow. Map out the worked explanations and diagrams. How does the data actually move? But Pass 3 is where the magic happens. Exam adaptability. This is where you rapidly switch scenarios, you take the exact same concept of clock speed and apply it to a banking system, then a retail database, then a self-driving car. You justify your choices every single time. This builds bulletproof adaptability so no exam scenario can ever catch you off guard.
All right, we've reached the end of the theory, but here is the massive unresolved problem. Now that you have the framework, you actually have to apply it. Knowing the moves on the chessboard doesn't make you a grandmaster if you never play the game. If you don't apply this exact framework to the hardest past paper scenarios under live time pressure, this entire strategy is pretty much useless. Checkmate is in the next step.
You now have the framework to beat the examiner's trap, but knowing the moves isn't enough if you don't practice them. Click the video on the left right now for a full past paper walkthrough applying this exact strategy to the hardest 0478 questions, and subscribe to our YouTube channel Ace the Exams at Ace the Exams Igcs to excel in your Cambridge examinations.